Hi everyone. Today we're going to talk about scientific notation. So scientific notation is how chemists write numbers. So we're going to write numbers a little bit differently than you might see if, say, you looked up something on Google. So let's talk about if you look up what the diameter of the Earth is on Google. And Google's going to tell you that the diameter of the Earth is 12.742 million meters. Which is a little bit of a strange way to write a number, but that's what they're going to tell you. How about if you look up the diameter of an atom? You'll find a different way of writing a number. It's going to say 5 times 10 to the negative 10th meters. Let's go ahead and write these numbers in regular notation. So 12,742 million, and then 0.000, you need 9 zeros here, and then a 5, and then 00. We can talk later about why those two zeros need to go on the end. So these two numbers are in regular notation. Regular notation is what you usually see when you write numbers. That's what we're most familiar with. But reality is we're usually dealing with numbers that are not too big and not too small. So using regular notation in our everyday lives to express how old we are or how much money we have in a bank account or something like that, regular notation is really helpful. The problem is chemists run into numbers that are either really, really big or really, really small. So for that, we have to use scientific notation, and that's that number there that we had for the diameter of an atom, because it's a really, really small number, and writing out all those zeros is kind of annoying. Okay, so that number in scientific notation, let's look at what that format is. What specifically makes scientific notation scientific notation? So what it is you have to start with one number, and then after that a decimal and the rest of your numbers. And that first number has to be between 1 and 9, meaning that first number has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be 10, it can't be 100, it's got to be one of those numbers. And then you have to put times 10 and whatever your exponent is. That exponent could be, any number. So 3.42 times 10 to the third, that's in scientific notation. 7.894 times 10 to the negative eighth, that's also in scientific notation. So what about not in scientific notation? So not in scientific notation would be 34.2 times 10 to the second, or 0.7894 times 10 to the negative seventh. Those are both not in scientific notation. Notice in these two numbers, you don't have a number between 1 and 9 to start with. First one is 34, the other one is 0. Those are not numbers between 1 and 9. In the first two numbers, you have a 3 and a 7. Those are between 1 and 9. So again, scientific notation is going to turn out to start with a number between 1 and 9, a decimal place, then the rest of your numbers, and then times 10 to the exponent that you need. Okay, so let's look back at our first example, the diameter of the Earth, the 12,742,000. So here we have just a regular number in regular notation. It's a really big number. We can kind of imagine that there's a decimal place at the end of this number because by putting a decimal there, we're not changing the magnitude of it. Okay, so we'll put that decimal in there and then we'll start moving it over until we have one number and then the rest of our numbers. And that number has to be between 1 and 9. So we got 1.2742. So now what do, right? 12 million is really different from 1.2742. 1.2742 is a lot smaller than 12,742,000. So here's where we're going to have the scientific notation part, the part that shows the magnitude of that number, how big it is. Okay, so now we need a times 10, and we'll put that in, and then we need a power. So what's our power going to be? Move the decimal over 7 places. So we're going to count over 1, 2, 3, 4, 5, 6, 7. So that's our power. We moved it 7 places. So 1.2742 times 10 to the 7th meters. While these two numbers look different, they're equivalent. They're exactly the same number. They're just represented in different ways. The top one, that's a number written in regular notation, and the bottom one is the same exact number written in scientific notation. About this other number, right? That was the approximate diameter of an atom. An atom is really, really, really small, so this is a really, really small number. So how do we put this back in scientific notation? We already know what the answer is supposed to be. It's 5.00 times 10 to the negative 10th. But how did we get that? First, keep in mind that this number already has a decimal. The one before it did not have a decimal. So the decimal in this number is right here, and we're going to move it over until we get scientific notation format. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots gets us over till we have one number, 5, and then a decimal, and the rest of our numbers, which are just zeros, times 10. And how many times did we move it over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our power is going to be 10, except it's got to be negative. So to the negative 10th, because this is a very small number. So we have a negative sign there. Basically, we're talking about the difference between multiplying by 10 to the 7th or dividing by 10 to the 10th, or another way to write that is multiplication by 10 to the negative 10th. Honestly, I think the easiest way to remember this is that big numbers are always going to have positive exponents because you're multiplying by 10, so you'll have a positive exponent. And small numbers, on the other hand, are always going to have negative exponents. So small numbers have negative exponents, and this will always be the case when you write a number in scientific notation. So let's talk for a second about how we do scientific notation on our calculators. Here's a picture of a TI-83 Plus. That's my calculator from high school. And so I'm going to show you on that one, but most Texas Instrument calculators are going to be pretty much the same. Let's figure out how many atoms fit across the diameter of the Earth, and we'll use our calculators to do this math. So you have to picture something like this, little teeny tiny atoms going all the way across, lined up across the diameter of the Earth. There's going to be a lot of them, right? The Earth is really big, atoms are really small. So this will look like our diameter of the Earth, which is 1.2742 times 10 to the 7th, divided by the diameter of an atom. So 5.00 times 10 to the negative 10th. And we'll divide those two numbers in our calculator because that's a pretty tough calculation to be doing in our head. Okay, so we're going to start typing it into our calculator. 1.2742, okay, now what? And I know your instinct is to put times 10 and then a caret, but we're not going to do that because our calculators are really super smart and they understand scientific notation. And if you write times 10 caret, it thinks you're doing multiplication, not writing a number in scientific notation. So here are the two buttons you're going to use. You're going to use second and then the comma button, which has an EE above it, and that's really important. So the EE tells you this is a number in scientific notation, and then you just have to tell your calculator what the power is. Okay, so here we go. Second EE, it'll give you an E, and then you're going to put the power in, 7, and then we'll do divided by 5.00, and then second EE, it'll give you an E, negative 10. Watch out for the negative 10, make sure you put a negative sign in there and not the minus. You want to use this button on your calculator. When you hit enter on your calculator, it's going to come up with an answer for you. It's going to say that your answer is 2.5484, and then it's actually going to have an E, but you know that means times 10 to the 16th, and this is atoms, so 2.5484 times 10 to the 16th atoms. Again, watch out on your calculator. The times 10 isn't actually written. It's going to show up as an E, but now we know that this is how calculators understand scientific notation. Instead of writing the times 10, it's going to show it as an uppercase E. So let's see what happens if we don't type scientific notation into the calculator the proper way. And again, absolutely do not do this, but I just want to show you what would happen if you did. So let's type our first number in, and we'll do times 10 caret instead of our new EE. So we'll type it in as 1.2742 times 10 caret 7. And then we'll go ahead, we'll type our other number in as 5.00 times 10 caret negative 10. And our answer here is 2.5484 times 10 to the negative 4th. Or in calculator speak, 2.5484e negative 4. I mean, wow, those numbers are really different. 2.5484 times 10 to the negative 4th and 2.5484 times 10 to the 16th. The times 10 to the negative 4th number, that one is really, really small, right? If you do times 10 to the negative 4, that means you're actually moving your decimal over 1, 2, 3, 4 spots this way. And we put some zeros in there. So this number is actually 0.0002548 And that means it's less than an atom, right? Remember, the question we were asking was how many atoms fit across the diameter of the Earth? Less than an atom? I mean, that doesn't even make sense. Whereas this number makes a whole lot of sense, that a lot of atoms would fit across the diameter of the Earth. So what's going on here? Why is it that this happened? The issue is that when you don't type your number in using scientific notation, then your calculator will follow order of operations. Follows order of operations, it's going to do your exponents first. So it'll do these guys, and then it'll take this number and multiply it by your big number here, and then divide it by 5, and then multiply it by this very, very small number here. And that's how you get a very small answer. So it'll follow order of operations, which is not what we want it to do. We want it to think of these two numbers as numbers in scientific notation, and the top one divided by the bottom one. Okay, so we're not going to do that. We're definitely not going to do that. Instead, we're going to do this. We're going to use our E button on the calculator, which again, we get by pressing second comma, and that'll give us the E. Okay, so I hope this helps a little bit with scientific notation.